My favorite kind of question, should be no shock to you. There's the formula, give me the aldehydes or ketones, but of course this is actually a double question because you got to list the aldehydes and you got to list the ketones. So we'll start off with the 5-carbon chain. Only one possible aldehyde there, the 5 carbons with the aldehyde group at the start or the end of the chain, depending how you think about it, pentanal. For the ketones, again, we're going to have the 5-carbon chain, but now we can put either the carbonyl group either at carbon 2 or at carbon 3, so 2-pentanone or 3-pentanone. 4 carbons, well, we've got to have a butane chain, ends with the aldehyde, and we've got to have a methyl group. Well, that methyl group can either go off carbon 2 as here or carbon 3 as there, so 2-methyl-butanal or 3-methyl-butanal. As far as the ketones are concerned, we've got a 1, 2, 3, 4 carbon chain. We've got to have a methyl group off one of the middle carbons, and we've got to have the carbonyl group off one of the methyl carbons. So there's only one way to do that. Carbonyl group takes priority over the methyl group, so 3-methyl, 2-butanone, etc. 3 carbons. Well, 1, 2, 3 chain ending in the aldehyde, so that will be a propanal. Got 2 more carbons we've got to put on. They've both got to be methyls, so that'd be 2,2-dimethyl propanal. And I challenge you to draw a ketone that is based on a 3-carbon chain, because of course it would have to go off that middle carbon, and that middle carbon is already occupied by 2 methyl groups. Now, those of you who left it like that will of course get close to all the marks, but always remember to look through to see if you have any stereogenic or chiral carbons. Do we have any? Well, none there, none there, none there, none there, none there, none there. But this one here, look at this carbon 2, the one that has the methyl group on it, an aldehyde group, and then an ethyl group, and of course a hydrogen. So we've got 2 possible isomers associated with that. Let's go ahead and draw it so that first of all we'll stick the hydrogen back. Let's have the aldehyde coming out to the side there. Call this an ethyl group because that's what it is as far as this carbon is concerned, and this is a methyl group as far as that carbon is concerned. So we have this enantiomer, and then just draw the mirror image of that. So just take this, reflect it in a supposed imaginary mirror there, and we end up with this. As far as assigning the absolute configuration, aldehyde is going to be 1 priority, ethyl 2, methyl 3, and the hydrogen 4, hydrogen at the back. So here we go 1, 2, 3. Going anti-clockwise, hydrogen at the back would be S, and then this one here, hydrogen at the back again, aldehyde, ethyl, methyl, going 1, 2, 3 clockwise, so that is the R enantiomer. Pretty pictures, and aren't they fun?